In this video, I will be working out the section 6.7 notes, which is the last section in chapter 6, and we will be solving radical equations. Now, it's going to be very important to check our answers for extraneous solutions. So, the process to solving an equation with a radical in it is to isolate the radical first before you try to remove the radical away from the equation. So here, if I have 2 times something plus 3 equals -1, I would start by subtracting the 3. Just like a normal equation. Then I'm going to divide the number out front. So I'm going to divide both sides by 2. Once the radical, or the root, is by itself on one side, you are then going to remove the root. So to undo a cube root, I am going to cube both sides. And so when you cube a cube root, it goes away, and you're left with x plus 1. -2 to the third power is -8. And to finish this off, I subtract the 1, and I get x is equal to -9. I do want to check that answer just to make sure it actually works. There'll be a few of these that don't, because sometimes you end up taking the square root of a negative, and that's not real, different things like that. So you don't have to show all this work, but in essence, when you go to check your answer, it looks something like this. So -9 plus 1 is -8. The cube root of -8 is -2. -2 times -2 is -4. And -4 plus 3 is -1, which is indeed what I want over here. So that checks. So then x is equal to -9. So I might not show all of that work today because some of that can be done in a calculator or scratch work, but that's the process that you use to check your answers here. So for number 2, kind of a similar thing. I really can't do anything right here because it has an exponent, so I'll just divide by 2. So I have x minus 2 to the 2/3 power is equal to 25. Now we learned up here that to undo a cube root, you can cube both sides. But to undo a power, you're going to use the reciprocal. So I'm going to raise both sides of the equation to the 3/2 power. And the reason why I do that is so that way these two powers right here will cancel each other out. So a power times a power, 2/3 times 3/2, those canceled and give you 1. So I'm left with x minus 2 on the left side equals, and then you take 25 raised to the 3/2 power. Now, since we're solving an equation, we have to keep in mind that we might get more than one answer here because they are asking us to take the square root of 25 and then cube it. And technically, when you take the square root of 25, you get plus or minus. So I'm going to split this up into 2 different parts. One of these would be x minus 2 is equal to 5 cubed. The other one would be equal to -5 cubed. So I will get 2 different answers here, one of which is 127. The other one is -123. And you can check those with a calculator. So if I go, there we go, right here. And for example, if I want to check 127, I will do 2 parentheses 127 minus 2, and then raise that to the 2/3 power, and there's that 50. Okay, so the other thing here to figure out is that both answers should work, so you should check the other one as well. Your calculator, though, let's see here. The calculator gets a domain error for plugging in -123. And the reason why it gets a domain error is because it thinks it's taking the root of a negative number. But I want you to look at the original problem. I know here we took the square root, but what type of root are they taking here? Right? So they are taking the cube root, and you can take the cube root of a negative number. So this is where your calculator might fail you a little bit because the operation that the calculator is thinking is not quite right. So both of these will check because I can take the cube root of a negative number, right? That's okay. I can't take the square root of a positive number. Or excuse me, the square root of a negative number, but I can take the cube root of a negative number. Anyways, the biggest thing here is just that plus or minus. Okay, so for number 3, I would divide by 2. That would be 27, and then I use the reciprocal power, which I'm not going to show all that work. I'm just going to write it like this. So that would be 2/3 around 27. Now, this is saying cube root of 27 squared. Now, the cube root never, ever gives you 2 answers. It only ever gives you 1 answer. So square root gives you 2, plus or minus, but cube root just gives you 1. So for this answer, it would be 3 squared, which is 9, and then we get back 6. And you can plug that 6 in, kind of like I showed you earlier. So let's see here. Need to move this up. There we go. So this would be 2 parentheses 6 plus 3 raised to the 3/2 power. Yeah. So just kind of be aware that the case that we saw in problem number 2 doesn't happen a lot, but sometimes your calculator is a little misleading. Let's go to the back. For number 4, you'll notice that I have a square root is equal to x minus 3, but I do have variables on both sides. But the one thing to note is the square root is by itself on one side. So I'm going to square it to get rid of it. But the problem is when I square the other side, I've got FOIL going on. So while this side is 5x minus 1, this side is x minus 3 times x minus 3. So this is going to be heavy on the algebra because I would use FOIL to get x squared minus 6x plus 9, and then I would have to set this equal to 0. So I'll subtract the 5x and add the 1 to see what happens. So this would be x squared minus 11x plus 10 equals 0, which factors down to x minus 10, x minus 1. So my 2 possible answers are 10 and 1. And I say possible because the time when to check your answer is when there's a variable on both sides. So all of the answers checked on the front, and the variable only ever showed up once on the problems on the front. So if you can remember that you don't have to check those, that's okay. But for these, when there's a variable on both sides, more than likely something's not going to work out. So these you can type into your calculator pretty easily. I'm going to go back to the original problem here. So I'm going to take the square root of 5 times 10 minus 1, and then I'm going to just write down that answer. So that's 7. And then I'm going to take right here 10 minus 3, which is 7. And that works. All right, what if I do 1? So square root of 5 times 1 minus 1 is 2. And then 1 minus 3 right here is negative 2. Well, that doesn't work out. So then the 1 is extraneous. So just put a slash through it, but don't box it up. So number 5, very similar process, but I have to subtract the 5 first. So I have the square root of x minus 3 is equal to x minus 5. Square both sides, which forces you to do some FOIL with x minus 5. So I would get x minus 3 is equal to x squared minus 10x plus 25. Subtract the x and add the 3. We get x squared minus 11x plus 28 equals 0. And then you're going to factor. I'll go up here to factor it. So that would be x minus 7 and 4. So then I can have x possibly be 7 or x possibly be 4. So I'll have to check my work here. All right, let's see. Scoot this up. There we go. Okay, so I'll check 7 first. Square root of 7 minus 3, close parentheses, plus 5, is 7. So yeah, 7 equals 7. Good. Let's check 4. So I've got 4 minus 3, close parentheses, plus 5. So 6 equals 4. Well, that's not true. So 7 is the only answer there. All right, the last one here is, I'll kind of show you this in a couple different ways, but you'll notice I have 2 variables, so I'm going to stick one over to the other side. So this is 2x plus 1 raised to the half power equals 3x plus 4 raised to the 1/4 power. So I have 2 different powers that I need to get rid of, and in essence this is a square root and this is a 4th root. But for me personally, it's easier just to leave the powers, because take the reciprocal of each one, like we did on the front. The reciprocal here would be 2, and over here it would be 4. Now I can't use both of those powers, so I have to pick one to use. If I square both sides, so when I square 1/2, it goes away. But when I take 1/4 times 2, it's a half, and that doesn't really help me. So what if I raise everything to the 4th power? What if I use the bigger power? So I'm trying to get rid of the fractions. Well, 1/2 of 4 is 2. And then 1/4 of 4 is just 1. So when I use the bigger power, both of the fractions will drop out. If I had just squared both sides, the fraction on the right would not drop out. So I'm going to square 2x plus 1. And I'm just going to go ahead and do some quick math here. That would be 4x squared plus 4x plus 1. And then you would set that equal to 3x plus 4, and then set it equal to 0. And then you would factor and then check your answers. I believe, yeah, this should work. 4x minus 3, x plus 1. So then we get 3/4 and -1. And just to kind of save some time here, you could check your answers, but this one's going to work. This one is not. There's your video.